we present GraphSeam, a graph-based neural network framework designed for UV mapping tasks. Automating UV mapping remains a huge challenge in computer graphics. Defining the optimal seams to cut and project a 3D surface into a 2D space requires to consider several factors. Minimizing the distortion is naturally one of them. Although the distortion is an important factor to consider, artists usually determine a trade-off in order to preserve the semantic boundaries in UV space. The projected texture on the 3D model is the result of not only optimized parameters such as distortion, but also a set of artistic best practices. This is where machine learning can help us benefit from these unobserved artistic cues. We use a character dataset throughout our experiments. For each 3D model, we use the vertex coordinates, normals, and discrete Gaussian curvature as input features. We also concatenate the seam label as we address this task in a supervised manner. Each feature is combined and expressed into an edge feature matrix for the classification task. The training on these features is carried out using a supervised inductive learning. The predicted seam outputs are then curated using two post-processing steps. The first one, skeletonization, is used to reduce the number of small shells in UV space. The second post-processing step is performed using a distortion Steiner tree. The distortion Steiner tree allows to find and add missing seams, reducing distortion for each shell. Our approach successfully provides an automatic solution framework to generate seams while preserving semantic boundaries. Based on the results, it is clear that the attention mechanism in GAT and the LSTM aggregation method in GraphSeam play a critical role in producing valuable results for seams classification. In addition, our post-processing steps offer a flexible way to improve the output for our graph networks. GraphSeam provides a robust framework to support and automate the tedious task of UV mapping.